DC motor. Electric motors are everywhere. Almost every mechanical movement that you see around you is caused either by an alternating current or direct current electric motor. Here, we are going to explore a DC motor. A DC motor is a device which converts electrical energy into mechanical energy. A current-carrying wire in the presence of a magnetic field will always have a tendency to move. This effect is known as motor effect. Want to watch the motor effect? Wind several turns of wire around a cork and suspend it from a clamp. Place this arrangement between the poles of a horseshoe magnet. Switch on the current. The cork moves. Now, reverse the direction of the current. The cork moves in the opposite direction. This experiment shows that the magnetic and electric fields interact to produce a mechanical force. This is the principle of an electric motor. The direction of motion is given by Fleming's left-hand rule. Fleming's left-hand rule. Extend the thumb, forefinger, and the middle finger on the left hand in such a way that all the three are mutually perpendicular to each other. If the forefinger points in the direction of the magnetic field, the middle finger in the direction of the current, then the thumb points in the direction of the force exerted on the conductor. A rectangular coil made of insulated copper wire is wound on a soft iron core. This is the armature. The coil is mounted on an axle and placed between the cylindrical concave poles of a magnet. Thus, the armature becomes an electromagnet when a current passes through it. A commutator is used to reverse the direction of flow of current. Commutator is a copper ring split into two parts, C1 and C2. The split rings are insulated from each other and mounted on the axle of the motor. The two ends of the coil are soldered to these rings. They rotate along with the coil. Two small strips of carbon, known as brushes, press slightly against the two split rings, and the split rings rotate between the brushes. The carbon brushes are connected to a DC source. When the coil is powered, a magnetic field is generated around the armature. The left side of the armature is pushed away from the left magnet and drawn towards the right, causing rotation. When the coil turns through 90 degrees, the brushes lose contact with the commutator and the current stops flowing through the coil. However, the coil keeps turning because of its own momentum. Now, when the coil turns through 180 degrees, the sides get interchanged. As a result, the commutator ring C1 is now in contact with the brush B2, and commutator ring C2 is in contact with brush B1. Therefore, the current continues to flow in the same direction. Again, brushes and the split rings lose contact when the coil turns through an angle of 270 degrees. The coil has a tendency to stop, but due to inertia of motion, continues to rotate till it covers 360 degrees. The process continues. Observe that the magnetic couple is maximum at 0 degrees and 180 degrees and 0 at 90 degrees and 270 degrees.